Hello children and welcome to your channel Sharda Educare. This is the video which is continuation of part 1 of coordinate geometry of 5.1 exercise children. And today we will be doing the remaining sum of your 5.1 along with your solved example. So we begin with the solved example number 2, that is, in this children I am taking the solved example and solving the sums from 5.1 which are related to the solved example. Now we are having solved example 2 in which we have got point A, point B and point C, and we want to show whether the point A, B, C are collinear or not. Collinear means they lie on one line. So how it is possible? When for doing this we will be finding the distance of AB and then distance of BC and also distance of AC, and we will check whether the sum of any two distance is equal to the distance of third. So let us check children. I have got point A, point B and point C. Let us assume this A is as x1 and y1, coordinate of point B are x2 and y2, and coordinate of point C are x3 and y3. Now first we will find the distance AB by using the distance formula. So by distance formula children, distance AB is equal to under the root x2 minus x1 the whole square, x2 minus x1 the whole square, plus y2 minus y1 the whole square. Distance AB by distance formula x2 minus x1. See, x2 is what? This is x2, this is y2. This is x1, this is y1, the coordinate. So x2 is 1 under the root 1 minus x1 minus 3 square bracket plus y2 minus 2 and then this minus y1 is 2 and then whole square. What are we getting here children? 1 minus minus will become plus 3 the whole square. 1 plus 3 the whole square plus minus 2 minus 2. Both are minus, so they will be added. So it will be minus 4 the whole square. What we are getting now? 1 plus 3, 4 square plus 4 square. 4 square will be 16 plus minus 4 the whole square will also be 16. 16 and 16 will be 32. That is 2 times 16. 1 time and 2 times 16 it can be written as, which is 4 root 2. So we got distance AB as 4 root 2. Let me write it here. Distance A comma B is 4 root 2. Now we need to find out BC. Now for BC again distance formula x3 minus x2. So here the formula will change, x3 minus x2, y3 minus y2. So y3 minus y2. Now which is y3? This is y3 and this is x3. So what is our formula by distance formula? x3 minus x2, y3 minus y2. So x3 is 9. Now we want to find out distance BC. Let me write here distance BC children. So BC x3 minus x2. x3 is 9 here. 9 minus x2, that is 1 the whole square plus y3. y3 is minus 10 and then minus y2 is again minus 2, it is a square bracket here. Now what you are getting, 9 minus 1 is 8 square children, plus minus 10 minus minus plus 2, so that would become minus 10 plus 2 the whole square. 8 square will be 64 plus minus 10 plus 2 would be minus 8. 1 is minus and 1 is plus, so subtraction. So minus 8 square and minus 8 square will be 64 again. So what we will have here, 64, this 64 plus again 64. So how many times 64? It is 2 times 64. So I can write down 2 times 64, which can be, square root of 64 is 8, 8 root 2. So distance BC I got, as 8 root 2. Now we will find out children AC, A and C. So what will be our distance formula now? x3 minus x1. Okay, here it will be changing as x3 minus x1, y3 minus y1. And which distance it is? Distance AC. Now we want to find out distance AC. So x3 minus x1, y3 minus y1. Now let us rub this children. x3. What is x3? 9 minus x1. x1 is what? Minus 3 and the whole square, plus y3. y3 is what? Minus 10 minus y1 minus 2 the whole square, minus 10 and this minus, and then y1 is 2. What are we getting children? 9 minus minus will become plus, 9 plus 3 the whole square, plus minus 10 will be minus 12 the whole square. 9 plus 3 will be 12 square, plus minus 12 whole square is 144, and this 12 square will be 12 square will be 144. Already this is plus 144. That means how many times 144 is there? 2 times 144. So we can write down 2 times into 144, and square root of 144 is 12. So we can say 12 root 2. So distance AC we got as 12 root 2. Let us write here distance A comma C is equal to 12 root 2. If you look at these points children, distance AB is 4 root 2 and BC is 8 root 2, then AC will be 12 root 2. Means if I add this 2, I am getting this. So I can say here distance AB plus distance BC is equal to how much? 4 root 2 plus 8 root 2, which is equal to, see here it is root 2 and root 2, so we can add this to 4 and 8, that will be 12 root 2. So distance AB plus distance BC is nothing but equal to distance AC. So we can say distance AB plus distance BC is equal to distance AC, and therefore point A, point B and point C are what? Collinear, because sum of the two distance is equal to the distance third, and therefore they are in one line. Moving to question number 2 of practice set 5.1. Previous to this we have done children whether the points are collinear or not from solved example. Now based on that exercise we are solving. The first sum is having the coordinate A, B, having the points A, B and C. A, B and C, their coordinates are 1, -3, 2, -5, minus 4 and 7. Let us find the distance by using the distance formula. By distance formula, first let us assume it x1 y1, x2 y2 and x3 and y3. These are the coordinates, so that will become easy for us to use distance formula. So by distance formula, first we will find out distance AB. In this what? x2 minus x1 under the root x2 minus x1 the whole square plus y2 minus y1 minus y1 the whole square. Now place the numbers, coordinates. x2 coordinate is 2 minus 1 the whole square plus y2 is what? Minus 5 minus y1 is minus 3 again, square bracket children. Then we are getting 2 minus 1 as 1 square plus minus 5 minus will become plus 3 the whole square, which will be equal to under the root 1 square is 1 plus minus 5 plus 3 will be minus 2 the whole square, which will be equal to under the root 1 plus 4, that is equal to root 5. So distance AB we got as root 5. Let me write it here. Distance AB is equal to root 5. Now we will find out distance BC again by using distance formula. So distance BC, now B and C, x3 minus x2 it will be now children. So by distance formula, all the distances we are finding by distance formula. One time we write, that is enough. So x3 minus x2 the whole square plus y3 minus y2 minus y2 the whole square. Now x3 is minus 4 children, then minus x2 to the whole square plus y3 7 minus y2, that is minus 5 square bracket the whole square. And what are we getting now? We are getting minus, both are minus, so it will be added minus 6 the whole square plus bracket 7 minus will become plus 7 plus 5 the whole square, that would be minus 6 the whole square is 36 plus 7 plus 5 12 square, and 12 square is 144, which is equal to 144 plus 36, that would be C 0, 6 plus 4 10, carry 1 8, 180. And this would be under the root 90 into 2. Now we will factorize it children. I'll look for 90 factorize, or let us look for 180. 2 9s are 18, 2 4s are 8, 2 5s are 10, then 3 1s are 3 5s are 3 5s are 15, and it is 5 1s are. Okay, again let me check. 2 9s are 18, 2 4s are 8, 2 5s are, 3 1s are 3 5s are, and 3 5s are 15. So we are getting 2 into 2 into 3 into 3 into 5. Clear? Okay. So see here children, 2 is for 2 time inside, 3 is for 2 time. So it will come out as 1 time out. This will also come out as 1 time out. 5 will remain inside. So total answer would be for distance BC as 6 root 5. So distance BC we got as 6 root 5. Let me write it here. Distance BC is 6 root 5. Let us find distance AC. Let me rub it. Let me write it here. Distance AC. So here the formula will change. That is A and C now. x3 minus x1 it will be. x3 minus x1 the whole square plus y3 minus y1 the whole square. Just you have to place the coordinates, children. Let us do it. x3 is what? Minus 4 minus x1. x1 is what? 1 the whole square plus y3 is 7 minus y1, that is minus 3 the whole square. And what are we getting now? This is distance AC, children, A and C. So minus 5 the whole square plus 7 minus will become plus 7 plus 3 the whole square. That would be 25 plus 10 the whole square. 10 the whole square will become 100. 125 it will be 125. So let us factorize 125. Let me factorize it here. 125 factorizing 5 to the 10 and 5 5s are 25, 5 5s are 5, 1s are, see, 5 2s are 10 and then 2, 25, 5 5s are 25, 5 1s are 5. So 5 5 5 3 times inside the root. So we can write it 1, 2 and 3 times. 5 is 2 times, so 1 5 will come out and 5 root 5. So AC we got as, distance AC we got as 5 root 5. So if I will check it, children, you can pause, children, and you can solve it. Let me just see how the points lie on a number line. That would be C. This is, what did we get? Distance AB plus distance AC. AB plus AC is equal to BC. Is equal to, so AB is how much? Root 5. And AC is how much? 5 root 5. And if I add both, I am getting 6 root 5. That is BC. See, BC I am getting 6 root 5. So what is that? Distance AB plus distance AC we got equal to distance BC. So sum of the two distances is equal to the third distance, and therefore point B, A, C are collinear. They lie on one line. You can pause the video and you can solve this, some children. Sub question 2 of exercise 5.1, question number 2. In this point L, M, N, we want to show them whether they are collinear or not. So let us use distance formula. Before that we will write here coordinate x1, y1, x2, y2, and this is x3 and y3, children. So by distance formula, first we have to mention first find the distance LM. Distance L comma M is equal to under the root x2 minus x1 the whole square plus y2 minus y1 the whole square. So let us place the values of the coordinate, children. X2 1 minus x1 minus 2 the whole square plus y2 is how much? Minus 3 minus y1 the whole square. That would be, children, 1 minus minus will be plus 1 plus 2 the whole square plus minus 3 and minus 3 both are minus, so they will be added. That would be minus 6 the whole square. See, sometime it can happen, I may miss minus, as I have done it in previous sum. It was to be minus but I wrote only 5, but since it was square, so I got it correct. 1 plus 2 is 3 square plus 36 minus 6 square will be 36. See, minus 6 square will be 36. Minus 6 into minus 6 minus minus will become plus. 6 6 are 36. Okay. Now 3 square will be 9 plus 36, and that would be 45, children, if we add. Okay. Now 45 you have to remove this you have to factorize. 3 ones are 3 5s are 3 5s are 5 ones are. That would be, if I write here, distance LM is equal to 3 into 3 into 5, which is equal to 3 root 5, children. So LM is 3 root 5. Let me write it here. LM, distance LM is equal to 3 root 5. Now we go for another distance, that is MN. So distance now M comma N, again by what formula? Distance formula. So here what I will read, x3 minus x2. x3 minus x2 the whole square plus y3 minus y2 the whole square. That would be equal to, placing the value now, x3 is what? 5 minus x2 is 1 the whole square plus y3 is 4 minus y2 minus 3 the whole square. That would be 5 minus 1, 4 square plus minus minus will become plus 4 plus 3 the whole square, which can be written, children, as 4 square is under the root 16 plus 7 square would be 49. See, 4 plus 3 would be 7 square and 7 square would be 49. Now 16 plus 49, let us add 49 and 16, 15, carry 1, that is 65. So we got distance LM is under root 65. If I want to factorize, what I would get, 65 would be 13 5s are, and that would be nothing but 65 only. So distance MN is under root 65. Keep it as it is. Now we will find out distance LN. Let me rub it, children. By distance formula only we will be doing it. Now we want to find out LN, distance LN, and what is it? x3 minus x1 the whole square plus y3 minus y1 the whole square. What would happen now? x3 is 5 minus x1 is minus 2 and whole square plus y3 is 4 minus y1 is 3 the whole square, which will be equal to, now 5 minus minus will become plus 5 plus 2, which is 7 square, plus 4 minus 3 is 1 square, and that would be equal to 7 square is 49 plus 1 square is 1, that would be 50 under root 50. So distance ln we got as root 50. Now we will write it here. Distance ln we got as root 50. Now if we compare them, we don't find any two sum is equal to third distance. So we can say lm plus ln or lm plus mn, distance lm plus distance mn is not equal to distance, which is the largest distance we will take first. The largest distance is 65, because if I take it inside, it will be root 45. So let me write it here, root 45. Now it becomes easy to find out which is the large distance. Large distance is mn. So we can say distance mn is not equal to sum of distance of lm plus distance ln. Therefore, point L, M, N are not collinear. They are not collinear. See children, when we want to decide whether the point are collinear or not, we have to see the largest distance, largest length. Here 45, this is 50, 65. 65 is the largest one, largest number. So this is not equal to this plus this, we should write it. And therefore the points are not collinear. Sub question 3 of question number 2. R, D, S, R, you can see on the board children, these are the coordinate. Let us assume at x1, y1, x2, y2 and x3, y3. And we want to say whether the points are collinear or not, as we have did other three sums. So let us use distance formula. By distance formula children, first we will find out RD, distance R comma D. You know children, by distance formula, x2 minus x1 the whole square plus y2 minus y1 the whole square. Just place the value children. x2 is 2 minus x1 0 the whole square plus y2 is 1 minus 3 the whole square, and we are getting 2 minus 0 is 2 square plus 1 minus 3 is minus 2 square. See here, we have to take care of minus. 2 square is 4 plus minus 2 the whole square will also be 4. You know, minus 2 into minus 2 will become minus minus will become plus, and 2 2s are 4. So what we got as distance RD, we got as root 8. Let me write it here, distance RD, R comma D as root 8. Now let us find a distance DS. Fine. Distance D comma S by distance formula again. Children, see, that would be x3 minus x2 plus y3 minus y2 the whole square. And what are we getting now? x3 minus x2 is 3. x3 is 3 minus x2 is 2 the whole square plus y3 is what? Minus 1 minus y2 is what? 1 the whole square. What are we getting now? 3 minus 2 is 1 square plus minus 1 is minus 2 the whole square, which will be equal to 1 plus 4, that is equal to root 5. So we are getting distance ds is equal to root 5. Let me write it here. Distance ds is equal to root 5. Now we will find out distance rs. So let us write it here. Formula will change children. R and S coordinate. x3 minus x1 it will become then. x3 minus x1 plus y3 minus y1. So just write here y3 minus y1 the whole square and place the coordinate here. See, x3 is what? 3 minus x1 is what? 0 the whole square plus y3 is minus 1. y3 is minus 1 and y1 is 3. So minus 3 the whole square. And what are we getting now? 3 minus 0 is 3 square plus minus 1 and minus 3 will be minus 4 square, which will be equal to 3 square means 9 plus minus 4 the whole square will be 16. That would be equal to 16 plus 4 is 25. So under root 25. Now let us write it here. Okay, let me write it here. Distance rs is equal to under root 25. Now if we see the distances which we have got, the largest distance is root 25. So root 25, if I am supposed to add other two distance RD plus distance DS, what I am supposed to get? Root 8 plus root 5. I can't add them. Okay, therefore we can say distance RD plus distance DS is not equal to distance RS. So this is the largest distance, root 25, and if we add them both we are not getting this. So therefore we can say point RDSR. Therefore let me rub this here. Therefore points R, D and S are non-collinear. They are not in one line. They are non-collinear. Children, you can pause and you can write down the sum. Sub question 4 from question 2 of 5.1. P, Q, R. The coordinates are minus 2, 3, 1, 2, 4, 1. We want to state whether they are in line or not. So let us assume x1, y1 coordinate. This is x2, y2 and this is x3, y3. Okay. Now by distance formula, let us find by distance formula. Find PQ. PQ is equal to x2 minus x1 the whole square plus y2 minus y1 the whole square. Now place the values. x2 is 1 minus x1, that is minus 2, plus y2 is 2, then minus y1 is 3 the whole square. What we will get? 1 minus minus will become plus, 1 plus 2 the whole square plus 2 minus 3 will become minus 1 the whole square, which will be equal to 1 plus 2 is 3 square plus minus 1 square is 1, that would be 3 square is 9 plus 1, which is equal to under root 10. So PQ is equal to under root 10. Now let us find out QR by distance formula, children. So QR is x3 minus x2, x3 minus x2 the whole square plus y3 minus y2, y3 minus y2 the whole square, which is, now place the value x3, x3 is 4, 4 minus 1 the whole square plus y3 is 1 minus y2 is 2 the whole square, then 4 minus 1 is 3 square plus 1 minus 2 is minus 1 the whole square, which can be written 3 square is 9 plus 1 square is 1, which is under root 10. So QR also we got under root 10 and PQ we got under root 10. Let us go for PR. So again PR by distance formula, children. Now in PR distance formula will be this coordinate and this coordinate, x3 minus x1. So x3 minus x1 the whole square plus y3 minus y1, y3 minus y1 the whole square. Now we need to place the value, children. x3 is what? 4. 4 minus x1 is minus 2 the whole square plus y3 is 1 minus y1 is 3 the whole square. Now equal to 4 minus minus will become plus, 4 plus 2, and that 4 plus 2 would be 6 square. See, 4 minus minus plus, and then 4 plus 2 is 6 square plus 1 minus 3 is minus 2 square, and minus 2 square will be 4. So 6 square will be, let me write it here. So PR is equal to under the root, children, 6 square is 36 plus 4, which is equal to 40. So PR is 40. Now look at this, PQ is 10 and QR is under root 10, PR is under root 40, PQ is under root 10 and QR is under root 10 again. So out of all these three, we will see which is the larger numbers, children. So if we see, we come to know root 40 is the largest one. So let us see by adding them. PR is equal to under root 40, which can be written as 2 into 20, which can be written as 2 into 4 into 5 is equal to 2 into 2 into 2 into 5, or just do this factorization. 2 2s are, 2 1s are, 2 5s are, 5 1s are. So 1 2 3, 1 2 3 and 5. That would be C. 2 are 2 times, so it will come out, and 2 5s are 10 will remain inside. So we got PRS to root 10. PRS to root 10. Now add this two and check what we get. PQ plus QR root 10 plus root 10, which is going to be equal to 2 times root 10. So what are we getting, children? PR is 2 root 10 and PQ plus QR is also 2 root 10. So this is first and this is second statement. So from first and second we come to know sum of these two length is equal to the third length, and therefore the points are collinear. So we can say that PQ plus QR is equal to PR from one end to and therefore point P, Q, R lie on one line, are collinear. Collinear means lie on one line. This was the last sub question of question number 2. You can pause the video and you can solve the sum, children. Now we will begin with solved example third or before practice set 5.1. The sum says verify whether the points P, Q, R are collinear. Means whether P, Q, R are in one line. We want to verify. So that can be done by using the distance formula, children. So we will use distance formula. By distance formula, you all know. Now let me assume P as x1, y1, Q as x2, y2 and R as x3 and y3. Now first we will find out the distance PQ. So PQ is equal to under the root, using the formula, distance formula, x2 minus x1, x2 minus x1 the whole square plus y2 minus y1, y2 minus y1 the whole square. So now we will have to place the values of x2 and x1 and y2 and y1. x2 is 3, then minus x1 is 6 whole square plus y2 is minus 7, then minus y1 is minus 6 square bracket. We are getting 3 minus 6, 3 is plus, minus 6 is minus, so it will be minus, that would be 3, but sign of greater number minus 3 square plus minus 7, minus will become plus 6 and square. Now see, 1 is minus, 1 is plus, you will have to subtract. So after subtraction, what will we get? Let me, minus 3 the whole square is 9 plus minus 3 the whole square means minus 3 into minus 3, minus plus 3 3s are 9. So plus. Now minus 7 and plus 6, 1 is minus, 1 is plus, subtraction, and 7 minus 6 will be 1, but sign of greater number and the square. What will we get? Under the root 9 plus minus 1 the whole square, minus 1 will be again minus 1 into minus 1, minus plus 1 into 1, 1. 9 plus 1 will be 10. Under the root 10. What is that? PQ. So we got distance PQ as under the root 10. Let us find the distance QR by distance formula. QR and distance formula, children, you know. Now x3 minus x2 the whole square plus y3 minus y2 the whole square. So placing the value of x3 is 3 minus x2 is 3 the whole square plus y3 is 3 minus y2 is again minus 7 the whole square bracket. What we will get? 3 minus 3 will be 0. So no need of writing it, just write 0. 3 minus plus 3 plus 7 the whole square, which can be written as under the root 10 square, which can be written as 100 under the root. It will be 100 under the root. Now we will find out distance PR. Again by distance formula, children, here. Now PR. So x3 minus x1, it will be x3 minus x1 the whole square plus y3 minus y1, y3 minus y1 the whole square. Place the values of x3. x3 is how much? 3. Then minus x1 is 6 the whole square plus y3 is 3 minus y1 is minus 6. So minus 6 the whole square, minus minus will become plus. So okay, 3 minus 6, it will be minus 3 the whole square plus 3 plus 6, 9 the whole square. 3 plus 6 will be 9, 9 the whole square. Now what are we getting here? Let me write it here. Minus 3 the whole square will be 9 plus 9 nines are 81, which would be 90. So PR we got as under the root 90. So QR is 100 under the root 100. Let me rub this, children. PQ we got under the root 10. Then QR we got under the root 100. And PR we got under the root 90. Now we want to see whether sum of two lengths is equal to the third length or not. Let us see. See which is the largest number out of these two. This is the largest number. Fine. So this would be QR under the root 100. We want to check whether this is equal to this 2 or not. So we will take PQ plus PR is equal to under root 10 plus under root 90. Now it is not easy for us to add because they are different number under the root. So what I will do, I will square them. Let me square this. It will be 100 here. And if I square this, what I am going to get? A plus B the whole square formula will be used here. So what am I getting? See. For PQ plus PR the whole square, I will be getting under the root 10 whole square plus 2 into under root 10 into under root 90 plus under the root 90 the whole square. Now root 10 the whole square would be 10 plus 2 into 10 into 90 will be 900 plus root 90 would be 90. 10 plus 90 is 100 plus 2 into 30, that would be 100 plus 60, which is 160 children. Now see, when I am adding PQ plus PR the whole square, I am getting 160, whereas QR the largest number is only 100. So what am I getting? I am getting PQ plus PR is greater than, finally I am getting PQ plus PR is greater than QR. That means if they would have been equal, that means the point would be on one line, but they are not equal. So we can say, therefore, PQ are non-collinear since sum of two length is not equal to the third length. We can say PQ plus PR is not equal to QR. Hence proved.